Good day. I'm Stuart Ibriones from Planet Enthusiasm, and today we're going to introduce, explain, and experiment about one of the gas law, namely the Charles law proposed by Jack Alexander Charles. So we all know, in society, we follow laws to maintain order. So did you know that all chemical matter follows certain laws as well? In fact, we can describe those laws by looking at the relationship presented by the law. Back in the 1780s, a French physicist named Jacques Alexander Charles noticed the different relationships between gas and temperature. He also observed the relationship between temperature and volume at constant pressure. He also did notice that gases expand when heated and contract when cold. It simply codes that as the temperature increases, the gas expands. Conversely, as the temperature decreases, the volume decreases. And this is the Charles law.
Hi everyone, I'm Riza Bigalapin from Planet Enthusiasm. For today's experiment is Charles' Law. Before we begin, safety first. Make sure to wear your lab gowns and gloves to protect yourselves from any spills and splashes. For today's experiment, we are going to use boiling water. So for safety reasons, I highly recommend to use temperature resistance glass. What we need in our experiment are the following: a piece of balloon, a tape measure to measure the circumference of the balloon before and after the experiment, a bowl with ice, boiling water, and a paper to record the before and after of our experiment. The first step in our experiment is to blow up the balloon and tie it. Then, measure the circumference of the balloon using the tape measure. The circumference of the balloon before the experiment is 34 cm. Do not forget to write the measurement of the balloon before the experiment. The next step in our experiment is to put the balloon into the boiling water and let it sit for 1 minute. As the water balloon sits on top of the boiling water, it gradually increases in size. It is because as the temperature increases, the volume of the balloon also increases. Let's now measure the circumference of the balloon after we let it sit for 1 minute in the boiling water. The circumference now of the balloon is 35 cm. Now let's see what happens when we put the balloon into the bowl with ice. Now, let's measure the circumference of the balloon. The circumference now of the balloon is 33 cm. Here is the final result of our experiment of Charles' Law.
So let's explain this experiment a little further. Charles' law states that when a fixed amount of mass of an ideal gas is kept in a constant pressure in a closed system, then its temperature and volume are directly proportional. What that means is that when temperature increases, volume increases, and when temperature decreases, volume decreases. What is an ideal gas? An ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles under normal conditions, meaning gases like oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means that they follow the laws of gases just like Charles' law. In our experiment, the balloon is blown up and filled with gas and air molecules. When the balloon is placed in a hot pot with boiling water, the energy from higher temperature water and steam molecules transfer to the lower temperature air molecules inside the balloon. That's why it expands. When the air molecules in our balloon increases, they spread further and further apart, increasing the volume of space they take up. The higher the temperature or the more energy or the air molecules get, the larger our balloon will grow. Or in other words, the greater the volume of space the gas will take up. When we remove our balloon in the boiling water, the air molecules in our balloon will gradually lose its energy that's been given, dropping back to its room temperature, causing the balloon to shrink in volume back to its original size. In our second portion of our experiment, we placed our balloon in a Tupperware with ice, which causes it to transfer in energy in the form of it from the warmer air molecules inside our balloon into the Tupperware filled with ice. As the energy is removed from the air molecules, they slow down. It drops in temperature and get closer and closer together, decreasing the volume of space they take up. The colder the air molecules will get, the closer together they will be. If the temperature of the gas is lowered low enough, it will go to a change in a state from gas to liquid. When we remove our balloon from a Tupperware filled with ice, the air molecules inside will gradually gain extra energy from the air and environment, raising its temperature, causing the balloon to increase in volume back to its original size. By changing the original volume of our balloon, we can see the directly proportional relationship between the temperature and volume of our ideal gas. This relationship is known as Charles' law. This law simply means that the hotter the gas becomes, the larger the volume, and that is the Charles' law. Wait, notice that the Charles' law is very different from the Boyle's law. Charles' law is a direct relationship. As the temperature increases, the volume increases as well. Well, that's all for our experiment and explanation of laws of gases. The Charles' law. Bye-bye.
친구 놈이 너는 좋아요도 보이는 네 얼굴은 훨씬 좋아 보여 새 남친과 찍은 사진 속 택 덕분에 추억